Yes, what does oxidation? What are the processes in oxidation?
Loss of oxygen.
No.
Gain of oxygen.
Gain of oxygen.
Loss of hydrogen and loss of
Electrons. And what else? There will be increase in. There would be increase in. What increases? Oxidation number, oxidation state. Okay. And from now onwards, when we are doing the past papers, you are not going to write or state reduction or oxidation as a loss or gain of hydrogen, because it is now excluded from the syllabus. Okay, so we are going to explain or state reduction in terms of electron, in terms of gain of electron, reduction in terms of loss of oxygen, reduction in terms of decrease in oxidation, oxidation in terms of gain of loss of electron, oxidation in terms of loss of oxygen, oxidation in terms of increase in oxidation number, but not in terms of hydrogen, because as I have told you, I have mentioned the hydrogen over there. For the previous past papers, when you will find the answer in the MS, but you are not going to practice writing hydrogen because now it's not in the syllabus. You always write the answer either in terms of oxidation number, in terms of electrons, and in terms of oxygen. Is this clear? So you just need to remember only one thing, whether oxidation or reduction, and just remember that the other thing is going to be exactly opposite. If you remember oxidation, gain of oxygen, so it means reduction must be loss of oxygen. In oxidation, there must be loss of electron, so in reduction, there must be gain of electron. In oxidation, oxidation number increases, so in reduction, oxidation number decreases. Is this clear to all of you? Okay.
Yes, sir.
Now let's start. The transition elements occupy the central block of the periodic table. Iron and copper are the typical transition elements. A redox reaction happens when iron filings are added to aqueous copper to sulfate. What is observed during this reaction? And it's of 2 marks. So it means we are going to write 2 observations. So who can tell me the correct answer?
We write the colors of copper and iron 2+.
What we will write?
About their colors.
Very good. See, they have asked you observation. Observation means when you are performing the reaction, what you will see. Yeah. So you are not going to see the reduction and the oxidation. You are going to see the color changes. So initially, the solution is of which color? There is an aqueous copper. So what is the color of aqueous copper? Blue. Blue. And then the solution turns? Fe2 positive aqueous is there, which is pale green. So we are going to write solution, or you can write blue solution turns pale green. Is this understandable? Yes. So this will get 1 mark. What will be the second mark? The copper solid is forming. And what is the color of a copper? Pink. Pink. You guys are not revising, right? So pink solid forms. Is this clear?
The copper is solid. No. Copper. Copper is pink solid.
Copper solid is a pink solid. So there is a solid which is forming during the reaction and it's of pink color. So we'll write pink solid forms. Is this clear? Yes. Yes, Sania and Manahil. Khatija, did you understand?
Yes, sir.
If anyone have any question, you can ask. Use the equation to explain that oxidation takes place in this reaction. So which one is oxidizing? Tell me, Fe or copper 2 positive?
Copper Fe.
Copper 2.
Copper 2 positive. After the reaction, what is its oxidation number?
0.
0. So its
Zero.
oxidation number is decreasing, right? So decrease in oxidation number is
Reduction.
reduction. Okay. So here they are asking about the oxidation. Okay. So if we look at iron, my classes. Okay. So yes. So if we look at iron, initially the oxidation number of iron is
0.
0, and here it is. So the oxidation number of iron is increasing. So it means iron is undergoing oxidation. Is this clear? So we
Yes.
write that as the oxidation number of iron changes from 0 to +2, it's oxidation. Is this clear? Use the
Yes.
equation to explain reduction takes place in this reaction. So which substance is undergoing reduction?
Copper.
Or 2 plus. You don't say just copper.
Copper.
The oxidation number of copper to positive changes or decreased from +2 to 0. It's reduction. Is this clear?
Yes.
Okay. Now I want you guys to write the answer for question number 2, and then Khadija, you will WhatsApp me.
Okay.
Yeah.
Even if you will slide.
Okay, write the answers quickly.
The question will be in numbering.
Question, just write the equation and then 1 and 2. Okay? You write the equation before and put the number 1 and 2. Then, yes, Khadija, are you done?
Yes, sir, I'll send you.
Okay. Yes, are you done? So we have to explain the oxidation using equation. So we can say that the oxidation number of iodide increases from -1 to 0, right? So the oxidation number of
सर
I-
ऑक्सीडेशन नंबर को चार्ज बोल देते हैं.
charge is a very informal term. Whenever we are discussing, it's a charge, yes. But when we are explaining the oxidation and reduction, we don't use the term charge. Instead, we always use oxidation. So it will be wrong if you write the charge. So the oxidation number of iodide increases from -1 to 0. It's oxidation. And who is undergoing reduction? Chlorine. The oxidation number of chlorine decreases from 0 to, where is 1? It's 0. 0 to -1. It's reduction. Okay, who is going to tell me the answer of 3A?
Because sodium is the oxidizing.
Sodium reduces titanium, so it means sodium is, but there is, okay, you can partially correct. Basically, if you look over here, what sodium is doing, sodium is taking place of titanium, right? So who can take the place of the other, the one which is more reactive, right? And that's what we have discussed in electroreactivity series as well. The one which is on the top are the most reactive one, and they can displace the elements from their compounds which are below in the reactivity series. So the correct answer will be sodium is more reactive than titanium. And in the way that you have told the answer, the correct answer will be sodium is stronger reducing agent. That's why it is going to reduce. There are so many reducing agents, but not every reducing agent is going to reduce titanium. To reduce the titanium, it must be stronger than titanium. Yes, explain how iodide act as a reducing agent. So if they are reducing agent, if it's a reducing agent, then it means what itself undergoing?
Oxidation.
Or can you repeat, Khatija?
Itself, it will undergo with the oxidation.
It itself undergo oxidation. That's what we have discussed. You can check in the notes. See, reducing agent, a substance reduces other substance and itself oxidizes. So if itself oxidizes, so what would happen? That if it oxidizes, whether it loses the electron or gains the electron, it loses the electron. So we'll write in that way. It is because iodide ion loses electrons and gets oxidized. As it loses the electron, it is actually providing the other substance that electron, so the other substance would gain that electron and get reduced. So that's why it's a reducing agent, because it provides the electrons to the other substance. Is this clear?
Yes.
Okay. Who is going to tell me the answer for 6A then?
Iron 3 is itself undergoes with the reduction.
And how? By gaining electron. Very good.
Yes.
Fe3 positive itself undergo reduction by gaining electron. Is this clear?
Sir, but how it is gaining electrons? Like at first in the product side, there is Fe3 plus, but in the in the reactant side it is Fe3 plus,
Yeah.
but in the product it is Fe2 plus. So how,
Yes, who can explain this?
What's that?
He's asking, it's a 3 positive on the reactant side, and on the product side it's 2 positive. So how it
And the negative charge.
Very good. Electron is a negatively charged. So when the electron is added, electron have a -1 charge, and iron 3 positive have a +3 charge. So when the -1 charge is being added, so +3 and -1 makes it +2, right? Iron have initially +3 charge, and the electron which it's gaining have a -1 charge. So when these two, when the -1 is being is actually added in the iron 3 positive, its charge would decrease to -2. Is this clear?
Positive.
Yeah, positive. Sorry. Yes, did you understand this?
yes,
Okay. What color change is observed? Yeah.
Purple. Green.
Why? Okay. No, but the thing is that there are two things which are formed. One is aqueous iodine and one is aqueous iron. So aqueous iron is which color?
Pale.
Pale green. And aqueous iodine is.
Brown.
So if both the things are formed, then which color will be seen?
brown.
Why pale green to brown? Pale green is the final color.
Colorless. That. Yeah, that's the problem. Colorless to know. Pale green or just one.
Okay. Now, listen again. The products, one product is iodine and the other one is pale green. What does pale green means? Yes, what does pale green mean?
Green.
It means light green. So if there is a light green and the other substance is a brown, so which color is seen to you? The light color or the darker color? Obviously, the darker color dominates. So the color at the end would be brown. Is this clear? And initially, it's iron 3 positive.
Yes.
So yellow to brown. and I negative does not have any color. Okay, so it's a colorless. So yellow to brown. Oh, sorry. Now describe the test for iron 3 ions. Can anyone recall this test? Okay. Add aqueous sodium hydroxide. To test any positive ion, we always use this reagent. Whether it's iron 2 positive, whether it's iron 3 positive, whether it's copper 2 positive, whether it's calcium 2 positive, whether it's aluminium 3 positive, for any positive ion to identify for its test, where we can use sodium hydroxide. And when we add sodium hydroxide, and if there is a iron 3 ions, you are going to observe red brown precipitates. What does precipitates mean?
The color of the solution.
No.
It's insoluble, so it will come at the top, like it will appear.
Yeah. When we mixes the two solutions, the one of the product formed is water insoluble. So it forms as a small solid particles. And those small solid particles are called precipitates. So if the color of the solution is red brown, so we just use in observation we just write solution turns red brown as we did over here. Over here, that it's yellow to brown. So we are just stating the change in color of the solution only. Okay. Okay, who is going to form this solution? It's very easy. Okay, just give me a minute.
There are cost of transport. Like, fine, PDF.
I'll tell you, PDF is not fruitful. That's my suggestion. For PDF can be fruitful when you are doing paper 1, that's fine. But for paper 4 and paper 2, no PDF is fruitful. तो पेपर 2 और पेपर 4 के तो आई सजेस्ट कि आप हार्ड कॉपीज ले लें, रीड एंड राइट के ले लें, रीड एंड राइट के टॉपिकल में लें, ठीक है? क्योंकि जब तक आप क्वेश्चन के साथ प्रैक्टिस नहीं करेंगे ना, तब तक आपकी उतनी अच्छी अंडरस्टैंडिंग क्लियर नहीं होगी, ठीक है? और जब आप कंटिन्यूटी में, और क्वेश्चंस क्या होते हैं, कंटिन्यूटी होती है कि वो एक पार्ट दूसरे पार्ट से लिंक हो रहा है, तीसरे पार्ट से लिंक हो रहा है, तो आप मोबाइल पे बार बार स्क्रॉल अप स्क्रॉल डाउन करना, और फिर एक नोटबुक में आपने सब नोट कर लिया, जब बाद में आप खोलेंगे तो आपको क्वेश्चन पेपर नहीं मिल रहा होगा, ठीक है? तो एमसीक्यूज तो आप सॉफ्ट कॉपी में करें, पीडीएफ वो आपको रोफ पेपर पे आपको वैसे टॉपिकल भी मिल जाएंगे, पेपर 2 के भी, पेपर 4 पे भी रोफ पेपर ऐप है। बट आई सजेस्ट कि अगर अच्छी प्रैक्टिस करनी है तो पेपर 2 और पेपर 4 के आपके पास हार्ड कॉपीज मिल जाए, if you want to do practice good. That's not one. Okay, just try this equation. How you are going to make this equation? Okay, yeah. It's S2O82 negative. Now try it. Yes. Who is done with the equation? Yes, you. Khatija.
Sir, I'm doing. Sir, this 2 minus is only for the oxygen, right?
No, it's the polyatomic ion. It's the net charge on the whole S2O8.
Okay.
Okay, who are done with the equation? Yes, are you done? Okay. Manahil, are you done? Okay, if you read the equation carefully, you will easily able to figure out what substances are undergoing a reaction, which are the reactants. So what are the reactants? Iron
Iron and
and
S2O.
peroxide disulfate, right? So iron 2 means iron with a 2 positive charge and peroxide disulfate means S2O82 negative, right? The products are iron 3
Iron.
and sulfate ion SO4 2 minus, and you have to put a 2 to balance the equation. Is this understandable? So see, there are these kinds of equations that examiner asks, but in these equations they always tell you these are the equations which you are unfamiliar with, but the examiner in that case gives you every reactant and the product, and afterwards you just need to balance them. Is this clear? Yeah, and it surely means if iron is oxidized, then the peroxide sulfate is reduced. And if iron 2 positive is oxidized, then it's a reducing agent, and peroxide disulfate is a oxidizing agent. Is this clear?
Yes, sir.
Okay. Now, these 4 questions are for you. Till then, I will just offer the prayers. Try it, and you can discuss with each other as well if you want to let you. That's it. Okay, just let me show these two, and then you can scroll, okay?
Sir,
Yes. How many questions are done? All? Yes.
Sir, only one.
Only one. Which one?
Nine.
3. Oh, previous one.
And what about 4?
It was just scroll up now, so that's why.
Okay. 9 is done. Okay, I'm going to check 9 till you guys complete 4 and 5. कितने हो गए भैया? समझ में आ गया? हाँ, 4 पे हो, ठीक है। कंप्लीट करो, आप काम करो। काम क्यों नहीं होगा? पेन क्यों रखेंगे? हैं? नहीं हो गया? समझ में आ गया? मैं भी आज करूँगा। Okay. What is the DRH?
5 or 6.
There is no DRH.
We are on the 5, we are then.
Reaction 1, if you see for A, reaction 1 converts chloride into chlorine. So if you see, here we have a chloride and here we have a chlorine. What is the oxidation number on chloride?
-1.
-1, because it is bonded with the hydrogen, so it will not be negative. Right? The sum of the oxidation number of hydrogen in chloride would be negative, right? And here its oxidation number in chlorine
0.
in Cl2, it's good, 0. So explain why this is an example of oxidation. Yes. Why it's
Oxidation is
the
increasing.
oxidation number increases. Okay. Beside this, what else I can write?
Using electron.
Good. The oxidation number increases. There, this is a one possible answer. Or instead this, you can write loss of electron. Is this clear? But we don't use loss of hydrogen. Okay. In marking scheme, you may find loss of hydrogen because it's from June 2016. But you are not allowed to write now loss of hydrogen. Okay. So both zinc and iron reacts with dilute sulfuric acid. The product of heating iron 2 sulfate and iron 3 oxide. The product of heating iron 2 sulfate are iron 3 oxide, sulfur dioxide, and sulfur trioxide. It means all of these three are what? Products. And this one is the reactant. Explain how you can tell the reaction involves oxidation. Yeah.
Like in reactant side.
No, just read the statement. The answer is in the statement A only. Yes, who is smart enough? In statement A, the answer is over there only.
Sir, can we say that the oxidation state of iron is increasing?
Very good. See, as a reactant, what is the oxidation number of iron? And when it becomes product, what is the oxidation number of iron? Its oxidation number increases. It means its oxidation. Is this clear? So, very good, Khatija. Good. The oxidation number of iron increases. Okay, now let's move to the question number 9. Bromine oxidizes aqueous iodide to iodine. So it means iodine is going to be the product and the reactants would be iodide and bromine. So bromine is going to be Br2, iodide is going to be I negative, right?
Yes.
And what it is forming? Iodine. So it must be 2
Yes.
iodide. So if iodide turns into iodine, then bromine must turns into
2Br.
bromide. So that's how the equation will be. Aqueous potassium iodide can be used to test the oxidizing agent. Describe and explain the color change when excess aqueous potassium iodide is added to aqueous potassium manganate. Yes.
From purple to brown.
From purple to brown, because we are adding it in a KMnO4 which is already purple, and on reaction it turns colorless,
Yes.
and iodide is initially colorless, on reaction it turns brown. So
There is a reason being found.
where is the reason?
Explain the color.
Describe and explain the color change. Okay. Purple to brown as KMnO4 is used up, and as it's used up, the purple color goes, the purple color fades, and iodine is formed. So as the iodine is formed, the solution turns brown because brown is the color of iodine. Is this clear? You don't understand.
Yes.
Okay. So we will be ending the class over here, and in the next class we are going to start electrochemistry. Okay. Okay. Take care, everyone. Allah Hafiz.
Love is.